Today I want to demonstrate the latest design. It's a controller for the A and B hydraulic pressure indicators in the cockpit. It's a compact design. As you can see, it's a small circuit board with a heatsink, which is well, the size of the heatsink is based on the size of the PCB, but the heatsink could have been a lot smaller because it gets hardly warm. It needs a power supply, of course, and this is the power supply I'm using for my test setup. It's a small PC power supply and outputs the required voltages, minus and plus 12 volts. Plus 12 volts on the red clip, ground on the black, and minus 12 on the orange clip. Well, you see it's already running. As long as the diagnostic LED is flashing, the firmware hasn't crashed. Well, what's more interesting is, of course, the indicators here, A and B, and I have a small Python application to demonstrate it. First, we need to connect. As you can see, by the way, besides the power supply connections, there are 4 wires for each indicator and a USB cable. The USB cable creates a virtual COM port, and of course we have to open that. First we select the COM port and then we open the COM port. Then we can move on to the tab for the indicator A control, the indicator B control, and well, sort of a gadget to simulate the indicators. First we go to indicator A. You have here a set point, any value between 0 and 1023. That's the accuracy. You have 1023 steps per 360 degrees rotation. And we can also decrement the set point by 10 or increment by 10. And here you have entry fields for the synchro stator offsets. Well, first move the right indicator A to 0. That's done, and let's do that also for indicator B. You see the needles swing a little, a small oscillation, but that is because there is a big step and the indicators are virtually not damped at all. Now we go to the simulate tab and we let indicator A, the right one, step by 1 at 200 milliseconds interval, and there it starts moving. Slowly, of course, but because the step size is very small. And we let the indicator B move by steps of, let's say, 10. And there indicator B goes. That's of course a lot quicker. You see a small jump. The small jump is due to a hardware issue that is difficult to solve, but if you move slowly by small increments, that jump is virtually not visible. You see indicator A is still moving forward really slow and almost at 1 whatever, whereas indicator B already has made a few full turns. We can of course move indicator a lot faster, step increment of 20 for example, and there it goes. And we can stop them, of course. A stopped and B stopped, and that's all there is actually. Thanks for watching, and well, move on to the next design, I would say. Bye.